update address, and maybe somebody's trying to do something funky with that. We're going to just turn that off, just to make sure that you don't get your bank account address updated when there's all this malicious activity going on. In a situation where you disable something, you can decide how long do I want to disable it. In this case, 30 minutes. And as I was talking, the developers here, this is all they have to do in code. They have a small sort of test, whatever it might be, for attack detected. It could be an access control failure, could be a blacklist style inspection of input, whatever you want to do. But after you say something bad happened, then you just create a new exception. And that's it. So imagine if you're looking into your logs after an attack happened, or during because you've been alerted, and you get this kind of information. The developer can put right here, suspected cross-site scripting attack, or access control year failed due to post tampering. Like, you get a large amount of information that'll be right there, and you'll know exactly what the attacker's doing as they probe your application. So I think that's pretty cool. So as I mentioned, these detection points, the other idea, or the other, we'll say, deliverable for this project was helping people understand how does someone attack your application. We know about vulnerabilities, but how does somebody probe for them? And basically what I started doing is, well, whenever I test an app, I do all these things, and half of them don't do anything. They're just probes looking for problems. But I started writing them down because most of them are not normal things, that a user would do. Because a user doesn't have a proxy running, they're not intercepting things and tampering with things. So none of these things should ever happen in a normal use case. So I started writing all of those down, and we have about 50 different attack points. This is a way a user could be doing something bad or looking for something bad. So we grouped them into logical areas and gave descriptions, and you can use this information now. I mean, if you totally throw away all the code that we have and don't care about any of it, you can just go look at this document and say, how could people be attacking us, and should we be doing stuff to think about these things? And some of them are pretty clever. But here's a few examples of some of the lower false positive rate type issues that's definitely an attack. And things that we don't typically think about. Like, if you have a page that's only designed, that should only receive GET requests, if you receive a post, well, first of all, does your page process it? A lot of pages will. But why? Why would anyone accidentally send you a post? And if they are, maybe they're trying to bypass some sort of filtering because a common product would only do XSS inspection on URL arguments instead of post variables. That was one way to bypass it for quite a long time. So maybe they're doing that. And if somebody evades presentation layer access control, now we know that presentation layer anything can't be relied on for security, but we also know that if something that we present to the user is changed or bypassed, then they must have taken conscious steps to do that through a Firebug type plugin or a proxy. So we know they're up to no good again. Another example, invoking an unsupported HTTP method. That's not something you do accidentally. So there's about 50 different points, most of them with very low false positive rates along these lines of ways to detect attackers. So what I want to talk about now is the actual demo code that we have. And this was released, it's online right now. You can download it. It's in Google Code. There's the URL. You can try and frantically write that down. But what this is going to do is put all of these ideas into practice. So if you thought you wanted to use this, I wouldn't want you to try, reinvent the wheel or try and figure it out because it's we're busy. So I have demonstration code that uses this, and it's ready to go, and you can just reference it to see how this works. So this is what I call AppSensor-Tutorial, and it's a lesson-based approach. Right now there are, you can't see that, about 5 lessons in there. And they demonstrate in very basic and concise examples how to detect an attack and how the response mechanisms work. So you don't have to look through a large amount of code to try and figure out all the different parts. It's what you see is basically the AppSensor type code. I decided to write it purely in JSP, so if you want to add a new lesson, you can just code it up and drop it in. And it's really simple to do. The code doesn't jump around too much. We don't use any Java filters. Not because it's not a good idea, and you probably will in your real app, but just to make it simple to follow and easy to understand the ideas. So each lesson has a simple form of some sort, like a text input or maybe a drop-down box, to demonstrate the idea. And you can run this application and actually see it working to defend it from attacks. So go ahead and try and attack it. And what you're going to see is as you attack it, say you enter a cross-site scripting attack here, it's not going to work, first of all. And then you're going to see the threshold count because we put this information to show you it working. And this detection point is called IE1. This is the threshold, 3 events in 30 seconds. And then what it's going to do in this case is it's going to log it first, and then it's going to log you out. And you can see those actions happening and actually see it all working in the code. So you can get a strong idea of how it works and show it to somebody if you need to gain support for this is what we want to do. So the first lesson in there is actually using the ESAPI validator and showing you that you can protect against malicious input just by using the ESAPI validator. And for each of these slides, what I did is I showed this is the relevant code in the JSP. Then you configure your property files appropriately. So in the second lesson, we changed that over and look for cross-site scripting attacks using AppSensor. And this is one of the areas where we decided to put in a blacklist inspection for cross-site scripting attacks or attempted attacks. And the idea here, I mean, you hear blacklist and you should go, oh, that's probably not good, because that's how we're trained to think, which is fine. But for attacker detection, blacklist is fine, because we're looking for, their tripwires, their alarms, any way the attacker might goof up and give us an obvious indication he's doing something dumb. The alert document.cookie, if you have an application that actually just strips that out and that's your cross-site scripting defense, that's just stupid. But you can certainly do it to look for attackers, because attackers love to put those proof of concepts in. So again, here's the code, and all you need to do for this. We use the verify XSS attack, we get a Boolean response, and if it's a potential attack, we throw that new AppSensor exception. And all the data gets logged, and then this counts against the user, and if they do it too many times, they'll get the response action. And the nice thing about this particular approach, you can define those regex patterns for cross-site scripting attacks right in the AppSensor's property. So you define with regular expressions how you want to look for these potential attacks. Keep it in your properties file, and whenever you use that Boolean check, it'll work just fine for you to look for attackers. Now the third lesson, what I want to demonstrate was the per page blocking response capability. And as we discussed, this is something that it might be appropriate for like an update address or maybe even a transfer funds in a bank. When you say, if we have too much fishy behavior going on near this flow of the application, we're just going to turn it off instead of risk an unauthorized action happening here. Not because we think there's a flaw, but somebody's up to no good, and that user is going to get denied access to that functionality until we can really figure out what's going on. And this is another very simple thing to do in code. You have your AppSensor user object, you check if it's active. And if it's active, if it's not active, the page you can display it's been disabled or whatever you want to say. Otherwise, display the page as normal. The idea here is to show that once you get this code in there and once you have the threat model discussion of how you want to handle this, it's trivial for developers to implement these kinds of ideas. 2 to 3 lines of code at most. And again, everything that you have, you control all your thresholds and your attack detection all through your properties file. So if you decide you want to change your thresholds or your tolerance for risks, you just change this file, push it back out, and you're ready to go. It's something that I think as this grows, if you deploy this across your enterprise, this is something you can manage centrally and really have some effective control. Now, along the lines of a per-page blocking type response, perhaps you say, well, we're going to disable this component across the board, because that's what we want to do. And a good example might be, think about a worm, perhaps a worm in MySpace. And maybe it would be smart to disable update status because you see all this crazy action going on. We're just going to say, you know what, we're just going to kill update status for now. We're going to look into what's going on. The whole site's running, everything's great. But this component that's been under attack because we've detected it is now turned off. And we can figure out the whole site is up, but that component's just temporarily disabled, and we can see what's going on. One of my previous talks on this, I do a whole section on trend monitoring and worm detection. I think this is an effective way of combating application worms. And the code for this is equally simple. Is active for everyone versus is active for user. So those are some of the different ideas for responses to attacks. Now, this has been extended by Colin. He's one of the core AppSensor team members, and he's been thinking about, what else can we do? What else might we want to do for responses? I listed a few of logging out the user, but he went and expanded this a lot further, and he has a whole list of new types of things. That's really hard to see. Let me put the slides online so you can look at this. But there's about 10 or 15 different response actions. And there's really no reason that these are the only ones you can do. You can define, in your application, in your organization, what you want to do when an attack is detected. But this framework gives you the capability to do that. You're looking for attacks, alarms are firing, and now you're making the call of, what do we want to do? How do we want to handle this user when we think they're attacking us? So what I'd like to talk about now is how we're using these ideas at Mozilla. We're using the app sensor thinking, the way of thinking. We don't have too many Java apps. We're not using the app sensor jar. But what we are doing is taking these ideas and putting them into our applications for attack detection purposes. Now we have an interesting situation. You all know about the browser, of course, and we have many millions of users using the browser, but we also have a lot of web apps. If you think of the add-ons website, the update server, Bugzilla, Firefox Sync, these are all web apps that we host, and we have millions of users using them every day. Now we have to defend those apps from plenty of people that don't like us for whatever reason. And we need to figure out between all that traffic, what is legitimate use, what's attackers, etc. The other interesting thing that you may or may not know is all of our code is open source. So the apps that we're defending, you can go and get the code for any of it right now. And if you find a flaw, please tell me. But everyone can look at it. So we're in a very interesting situation there. So one of the nice apps that we have, or nice web services that we have is Firefox Sync. I don't know if anyone's tried it. It's coming out in Firefox 4, and it's an add-on right now. But basically, it's going to let you take your bookmarks, your history, passwords, all that stuff, and encrypt it and store it on the server so it can be synced to all browsers of your profile on different machines. And we've taken an interesting approach in that it's encrypted from the point it leaves your machine. So if we can't monetize it, we can't do anything, we can't mine it, it's all encrypted. But it's still a nice, interesting area for an attacker to go after. Could they pull down somebody else's encrypted data? If they did, could they get access to that data itself? We think no, but we also want to put in detection points to find these attackers, because we're of the same mindset here with AppSensor that it's silly to just hope that our applications are secure and just leave it at that. We're going to look for these attackers and get rid of them. So some examples of things that we're doing, if you send a URL request to Firefox Sync and the username in the URL doesn't match the credentials because maybe you switched them around, you're checking for access control failures, we'll know about that. If you're trying to reset your password and you say, oh, this is a reset code, I wonder if I can increment by 1, even though it doesn't look like you can. We'll see that too, and we'll get that information in real time, and we'll see what exactly you put into that field. So if you tried to do a cross-site scripting attack, I'll see that, or again, incrementing it, or whatever you're doing. Another example, if you try and delete an account and you decide to not send the password parameter. Again, a normal user, this would never happen. But in this scenario, that's somebody doing something bad, looking for a flaw. Now, I don't think there's a flaw there. We've looked at the code. I don't know exactly how a flaw could be there, but there's lots of weird situations. I think even in WebGoat, there's a good example where the error handling, if you don't send a parameter, the error handling fails open. And those are the kinds of things. We don't have that flaw, but if somebody's looking for it, I want to know. I want to know they're bad, and then we can take action against them. So in our applications, we're doing threat models of the different web apps, looking for possible ways of it being attacked, and building in those detection points. Now another interesting thing is looking at an application that you don't have control of the source code, and maybe this is a situation for a lot of you. How do you defend those apps if you can't put the detection points in there? And one way you can do it is you can do trend monitoring on the URL request. And depending on how much information you have in the URL, you can actually glean a lot of information out of that. And I have a slide coming up on the trend monitoring we're doing, but it is one way of gathering information, depending on how your URLs are set up. Now I mentioned that we're not necessarily using the same app sensor type code. What we're doing instead is funneling our information to a security integration manager, and we're monitoring that in real time. So that's a different way of doing it if you have that set up in your organization. So set up your app sensor events in whatever format you're using to send the message to your SIM, and then you can monitor it using that tool. One possible example is to use something like common event format, and this is what we do. This works with our SIM, and we have this coded into our applications. Instead of doing the new app sensor exception, we throw a Ceph event. And that flows immediately into the SIM, and we see the attack information in real time. So here's an example of what we do. It's very similar to what we saw before. Oh, you can read that one. So we have a check of, is something going bad? this is authentication. So if authentication fails, then we throw the Ceph event, and all this information goes straight to our centralized reporting system. And this is giving us a lot of power because we can do data analysis on all these events.